With this Casio scientific calculator, you can solve derivatives and integrals. If you want to see how, keep watching. It's actually quite simple. Look, I'm going to solve a derivative exercise and an integral exercise directly with the calculator, and then I'm going to solve those same two exercises quickly by hand. We can check to confirm we're getting the same result, and we will, as long as we do it correctly. Let's get started. So let's quickly solve a derivative exercise. The exercise we're going to solve is the one that's appearing here, which says, differentiate the function f of x equals 2x to the fifth minus 3x to the fourth plus 2x minus 1 and evaluate it at x equals 2. Come on, let's do it. So the first thing we have to do is press this little button that says catalog. Then we're going to press OK. And now we're going to press OK. Again, OK, because we've already selected the one that says derivative, that's it. Once we're there, we just need to enter the function we have to differentiate. So we're going to enter 2x to the fifth x. Here we press to raise it to the fifth power. I move over with the arrow, and we enter minus 3x to the fourth minus 3x, raised to the fourth power. Then it's plus 2x minus 1, plus 2x minus 1. That's it. Then it says, we have to evaluate at x equals 2, right? So I move over with the arrow and enter a 2. That's it. That's all I have to do. We just hit run and that's it. We're done. The result will be 66 easy, right? All right, now let's see how we can do it. To solve a definite integral, we're going to solve the one we have here, which is the integral from 2 to 3 of the function 3x squared minus 5x with respect to x. So let's do it. For this, let's clear this again, hit catalog, then click again where it says analysis, and go to where integration is. We hit OK and enter the function we agreed on, which was 3x squared minus 5x, right? Well, I'm going to put the parenthesis, but it's really not entirely necessary, okay? So I put 3x squared minus 5x. We close it. The parenthesis moves me forward with the arrows, so I can enter the integration limits. Up here goes a 3, and down here goes a 2. There we go. Now we have the definite integral from 2 to 3 of the function they're asking me for, right? We executed it, and it's showing the result as 13 over 2. If we want to convert it to decimal, we just click here where it says Format, go down with the arrow and hit OK, and it's telling me that it's 6.5. In this case, if we're solving a problem, for example, about areas, then we'll know that it's 65 square units, right? All right. Well, that's it for now. So I'm done with the calculator part. You can stop here if you are only interested in knowing how to solve exercises. But if you want to see if what I just did is actually correct, then keep watching the video, because now I'm going to solve them by hand, directly. So let me copy the exercise then. Done. I've written it down, so let's find the derivative of this function. Since it's a polynomial, it's pretty easy to differentiate, right? Multiply 2 by 5 to get 10 right x and reduce the exponent by 1. Subtract 1 from the exponent. For 1 0x to the fourth power, then multiply 4 by 3 to get 1 2 right x and subtract 1 from its exponent. And then plus. The derivative of 2x would be 2 times 1, which in the end, 2 times 1 is simply 2, right? All right, so I'll leave it like that. And well, the derivative of minus 1 would be 0. So I won't write anything else. I could put minus 0, but let's just leave it. All right, now we have the derivative of the function. So the next step would be to evaluate this same derivative, but at 2 as it says. Remember, the answer was 66, right? Let's check if we get the same result. So we write 10 times 2 raised to the fourth power, minus 12 times 2 raised to the third power, and then plus 2. Continuing here, I would have 10 times 2 to the fourth power, which is 16, minus 12 times 2 to the third power, which is 8, and plus 2. Continuing, 10 times 16 is 160 minus 12 times 8. 8 times 2 is 16 carry 1. 8 times 1 is 8. Add the carried 1 to get 9 plus 2. So what I have left is, in total, I'll do the subtraction here. 160 plus 2 is 162, And from this, we're going to subtract 96. Here, 12 minus 6 is 6. Then 5, then 1. 5 minus 9 is 6. See that I'm getting exactly, the same result. We're getting 66. So, what we did with the calculator was correct, right? We were able to verify it quickly. And obviously, it had to be correct, right? Casio's technology is actually quite reliable, so you shouldn't have any doubt that if you enter it correctly, it will give you the right result. All right, now let's move on to the next exercise, which was a definite integral. We had the integral from 2 to 3 of the function 3x squared minus 5x. And of course, we add the dx. And we're going to integrate. Excuse me? Don't forget that in this case, when we solve the integral, we're not going to add a c, since we have a definite integral. So let's go ahead and integrate. Here I get 3x cubed over 3, right? So it's minus. Write the 5, write the x, increase the exponent by 1, and divide by 2. It's important to note, I'm not explaining in detail why we're doing it this way. I assume viewers of this video already know how to take derivatives and integrate. We're just seeing how it's done with the calculator and checking if it gives us the right answer. That's it. Okay, well, so let's evaluate from 2 to 3. Here, since 3 divided by 3 is one we don't need to write that anymore, so let's go ahead and evaluate first at the upper limit. So I have 3 cubed minus. Here we have 5 times 3 squared. Notice that I'm evaluating at x equals 3, and this is over 2. Then we're going to subtract the function evaluated at the lower limit from this. Well, this right here is already evaluated at the limit. So now we have x cubed evaluated at 2, which means it would be 2 cubed minus 5 times x squared, but x right now is 2 and over 2. That's it. That's how it would look, right? All right. Let's continue with the calculations. 3 cubed is equal to 27, and here we have minus 5 times. 3 squared, which is 9, so here I would have 5 times 9. This is over. 2 again. 2 cubed is 8, so I'll note that. Also, minus times, minus is plus. And here we have 5 times 2 squared, which is 4. Well, I'll just write it as 4 right away, and this is over 2. All right, let's continue. I have 27 minus 5 times 9, which is 45, over 2, so I have 45 halves. Next is minus 8 plus 5 times 4, which is 20 divided by 2 to get 10. All right, I can quickly do the operation here, right? It's simple. We have 27 minus 8. Let me do the calculation first. The integers 27 minus 8 are 19, and 19 plus 10 is 29. So I have 29 integers minus 45 halves. So let's go ahead and do the operations. 29 times 2 is 58. Minus 45 times 1 is 45 over. 1 times 2, which is 2. First, 58 minus 8 is 13 below. We have a 2. So 13 divided by 2 is 6.5. That's it, right? In this case, I repeat, if we were working on an area problem, then we already know that here it would be square units. Okay, so I'm going to write it down right away. I want you to see that we're getting 6.5. And with our Casio scientific calculator, we get exactly the same value. And well, that's it for today. I hope you found the video helpful and enjoyable. If you want me to keep making more videos explaining how to use the functions of this scientific calculator, please let me know down below in the comments. See you next time. Take care and behave yourselves. Bye-bye.